Okay, let's give you guys some more practice. So use cylindrical coordinates to work out the volume of this solid. So here the solid is bounded from the bottom by this surface and bounded from above by this surface. And if you want to know the radius of this circle, put 0 into the z and then work backwards to find the radius. Anyway, use cylindrical coordinates to work out the volume of this solid, to work out V. So press pause and have a go. Okay, so to do this, looking at the inner integral, we've got to work in terms of the height. So we would start at the bottom surface, and then move all the way up and stop when we hit the top surface. That's this surface here. We would start at the bottom of the solid, which is this surface here, and then we would move all the way up and stop when we get to the top surface. We would start at the bottom of the surface here and stop when we get to the top surface. So really we need to start looking at this. We need to start at this surface, which would be x squared plus y squared all squared minus 1, and then we will need to stop at this thing here, 4 minus 4 x squared plus y squared. But the thing is, we need everything here in terms of theta, r and z. We can't really work in terms of x and y. So we need to convert these two surfaces into cylindrical coordinates. So looking at those two surfaces, so this thing here will then become this, and then this thing here will then become this. So hang on, let's try and understand why. Looking at this x, so remember in cylindrical coordinates, x equals r cos theta and y equals r sine theta. So you would put this into here, square it, that will then give you this. Put this into here, square it, and then that will then give you this. And do the same for this and for this. So this whole thing here will then give you this. This thing here gives you this. So hang on. So we are currently, so this here is the bottom surface. This here is the top surface. So now it's blah blah. The top surface, sorry, the bottom surface is given by this, and the top surface is given by this. So going back to our original problem, we need to integrate it from the bottom surface to the top surface, and then in terms of r, we would need to do it from r equals 0, because in terms of r, look what's happening. We are integrating from a radius of 0 to a radius of well, if you want to know this radius, put 0 into the z. So that would then become 0 equals 4 minus 4x squared plus y squared, and then that would become, add this to both sides, so that would be 4x squared plus y squared equals 4. 1 equal, well, it's going to be a radius of 1. This thing here is a radius of 1. So so you're integrating from a radius of 0 to a radius of 1. You're integrating from a radius of 0 to a radius of 1, from a radius of 0 to a radius of 1, from a radius of 0 to a radius of 1. So from a radius of 0 to a radius of 1. So now looking at the angle in terms of theta, you're actually integrating from an angle of 0 all the way around here. So in terms of the angle, you're moving around 360 degrees. So you're really integrating from pi equals 0 to pi to 2 pi. So the volume is given by this. So now it's just a matter of evaluating this triple integral. So let's try and do it. So looking at this, remember there's like a sort of 1 here. So when you integrate this with respect to z, that will then give you z, and you're integrating from here to here, from here to here. So now we can put this into here. That will then give us this thing here, and then put this into here. That will then give us this thing here. and then you've got your R here, you've got a R here, and then you've got these two, so that will then take us to here. So now now multiply out the now multiply this out, so that would be 4x, this would be to the power 3, this would be to the power 5, this would be R, and then merge these two together. That will then give you this, and then integrate it with respect to R. So looking at this inner integral, we need to integrate it with respect to R. So integrating this will give you R squared, integrating this R to the power 4, R to the power 6, from 0 to 1, from 0 to 1, and then put 1 into here, 1 into here, 1 into here. That will then give us this, and then take away, put 0 into here, put 0 into here, put 0 into here. That will be 0. So that will then take us to here. So now merge all these three together. That will then give you 8 over 6. Simplify it. That will then give you this. Now integrate it with respect to theta. That will then give you this thing here, from 0 to 2 pi. So put 2 pi into here. Blah blah. The volume is given by this. Okay.